Brew.
Don't waste my battery. This is not making the final cut. That's blooper reel at best. Come on. Hello everybody, I hope everyone's doing well in quarantine. I miss you all. Now obviously, I'm stuck here in quarantine. I've been released from the basement under the one condition that I wear these glasses the whole time. So, I hope you all like them. This presentation is how you solve series circuits. Now, if you go to slide number 9, you'll see this same setup. I'm going to do a little extra stuff, more so than what's on the presentation. So if it doesn't match totally with what it's asking, that's okay. I'm doing more stuff. So when you get to the other questions, hopefully this will serve as a good guide to follow. Step 1, write down your equations. Where are your equations? Perfect. The reference table. I assume yours are all laminated by now. If not, remember, just Google New York State. No, just Google physics reference table, and it's the first one that pops up. So you want to get the ones that say series of circuits, and I forget the order, but the I total equals I1, which equals I2, which equals I3. And remember that's true because if an electron leaves here, it has to go through the whole entire circuit. So current is just the rate at which electrons are moving around. How many electrons you have go by a point each second. So since there's only one loop, the same electrons need to go through every part. They can't just leave the circuit. The next one is your voltage, and this is V1 plus V2 plus V3. That equals your total. We got 3 here. So this 9 volts is going to get split up between those 3. Some will get more, some will get less. And then the last one is your equivalent resistance. That's what the EQ means. And that's R1 plus R2 plus R3. Now these you don't need to write down every time. They are in your reference table. I just put them up here because I'm going to talk about them again. On your presentation, the first thing it says is what is the potential difference across each resistor. So that's a tricky question because we need to figure out V at each one. We're going to be using Ohm's law, but before we do that, we need to figure out what the heck the total I is. And to do that, we need any of the I's, but we don't have any of the I's. Tricky question. That's why I picked this one to go over. We know the total V. We know this all equals 9 volts. We don't know what this equals. And we could figure this one out because we have 3 resistances. So once we have these 2, we can solve for the third one and get on our way here. So we'll do that. So R1, we'll just call it this one. You get 100 ohms plus 300 ohms for R2 plus exactly 450 ohms, and that's 100 plus 300 plus 50, just like it says on slide number 9 in your presentation. So now that we have those, we're going to go to the most important equation here, and that's Ohm's law, V equals IR. So we know our total V is 9 volts. We're looking for the total current, and we just found out that we have 450 ohms. So solve for I here to get the number of amps. 9 divided by 450, 0.02 amps, 0.02 amps. Not that many, but it would still shock you. So now that we know that, we know the current here, I equals 0.02 amps. The current here is I equals 0.02 amps. Current here is I equals 0.02 amps. And that's, again, in a series circuit, the current's the same everywhere. So we got the total resistance, we found the total current, we know the total voltage. We know the individual resistance at each one, we know the individual current at each one. So the last thing they could ever possibly ask you is what is the voltage at each one? So what's V1, what's V2, and what is V3? Oops, that's a question mark. And to do that, we're just going to use Ohm's law again. So basically it's like F equals MA of circuits. Whenever you don't know what to do, just go use Ohm's law. So we have V1 equals I1 times R1. So we're looking for V1, we know I1, 0.02 amps times R1 is 100 ohms. You could solve that. That equals 2 volts. You repeat this process with V2, I2, R2. You do the same thing with V3, I3, R3. Maybe I'm going to play some music in the background here as filler. I don't know. The current is the same, 0.02 times the resistance there is 300 ohms. And then V2, so what is that? That is 6 volts. V3 with the same 0.02 amps times 50. I've always said it was 50. Never said 200. And what is this? 1 volt. I know you may not have to do this every time, but if you have the time, it's a nice check because your voltages should add up to 9 volts. So if you take 2, 6, and 1, you get 9 volts. So not necessarily everything you had to find on slide number 9, but it's everything you could do with the circuit. We were able to find the total current here, the total voltage, the total resistance, and we were also able to find the individual resistances, the individual currents, and the individual voltages. So everything they can ask you about. The only trick would be if they made it a light bulb instead of a resistor. Like, subscribe, turn the bell notification, donate, find my Patreon. Thank you to our sponsors, Clear Glasses.